Hi, this is Bill Punch with another video in a series of videos from Michigan State University on the topic, the practice of computing using Python, CSE 231. This is a follow-up to the first dictionary video. This is a simple application of dictionaries doing word frequency counts in a document. Let's go ahead and get started. So at the very top here, I want to tell you what the essential idea is that we're trying to accomplish. We are going to use a dictionary to store words that we extract out of a file. Those words are going to be the keys, and the counts of the number of times that word has occurred in the file are going to be the values. So the words in the file will be the keys, the number of times they occurred will be the value. That's the big idea. A lot of the rest of this is kind of details, and so we'll use the dictionary as a file as a way to store the keys of a file. We have to do a lot of work to process each word in the file. In particular, the string capital IT, the string capital or lowercase it, and the string IT with a comma after it should all count as the same word if we're trying to do a frequency count. And we have to make sure that when we do that work, we convert all those words to the same form, lowercase it. When we do the processing, we'll remember that if a key or a word doesn't exist in the dictionary, we're going to create it with a count of 1. If the key word does exist in the dictionary, whatever its count is, we're going to increase its count by 1. And at the end, we're going to print out the words both in frequency order and in alphabetic order, because that'll just be so cool to do. We're going to work with a really short file, Gettysburg Address. Gettysburg Address is a nice short file, has some very interesting words in it. That'll be easy to work with. We'll come back and take a look at this as we go through. We need a main function. The main function doesn't do a lot of stuff. It's pretty easy to do. It's going to open the file, which is what these two lines will do, create an empty dictionary, call the getWords function, which we haven't defined yet, takes in a file object in the dictionary. Nothing is returned, but because the dictionary is a mutable object, it's going to be changed in place. We'll close the file when we're done. And then we'll call the two functions, one to print everything alphabetically, one to print it in frequency order. Nice main function, makes it clear what's going on. We can easily follow what's happening. By the way, there's a print statement in here. How many words are there depends on the length of the dictionary. GetWords is doing a lot of work for us, and I want to show you that in particular, this is the whole sort of crux of the issue we're trying to solve. If the word's in the dictionary, add 1 to it. If the word isn't in the dictionary, put it in with a count of 1. The rest of this stuff from here to here really has to do with all the word processing that we need to do. So let's take a quick look at that. We have an open file object coming in. We're going to read each line from the file object, and we're going to strip it. That is, we're going to take punctuation, not punctuation, but white space off the end of the lines like a carriage return, like a tab. And if you look at our file, in fact, there are tabs in the file, so we have to pay attention to that. Once we get our stripped line, we're going to split it, which creates a list of words, space separated. For each word in the word list from the split, we're going to lowercase it because that's what we want to do. We're going to strip string.punctuation off the end of it, so commas, periods off the end of each word. And then here's an interesting question. We say if word. What does that mean? If we go back to our file, we see some interesting stuff. First of all, we have these double dashes in the process. If we isolate that as a word, strip the punctuation off both ends, we end up with an empty string, which is not something we want to process. What about this? Here's an empty line. If we process that and strip it all out, it will also end up in an empty string. And remember, when we say if word, we are basically saying, is this word not the empty string? So if it's not an empty string, we're going to do the processing plus 1 for the count if it's there, set it to 1 if it's not. At the end, our dictionary is going to be filled up with words and counts. Like I said, nothing's passed back. All things are made in place on the dictionary, so we don't need to. Here's the print alphabetic, and here's the essential idea. We collect all the key value pairs from the dictionary. We can't sort a dictionary, but we can sort a list, so we're going to sort the list of key value pairs, print it out nicely in columns in alphabetic order. That's the essential idea. Hey, what about sorted? Can't sorted help us here? Let's make a dictionary and run the sorted function on it. What do we get? We get sorted keys because, as we have said before, everything that you do in a dictionary is key oriented, so that doesn't really answer our question. By the way, let's define this function, and let's define the main function too, so we have these guys available to us. So we need to do more work than that, and here's the work that we're going to do. This upper part is the main idea. We have a pairs list. We're going to go through the dictionary items and grab the key and the value, and we're going to create then a tuple for each of the key value pairs and store them in the list, so at the end we get a list of tuples. We are then going to print some stuff to make it nice and pretty, but the hard work is going to be done by this operation, pairs.sort. Remember, if we do a sort on a chunky item like a tuple, we're always going to sort on the first value in each tuple, so this will sort things in alphabetical order. Then we're going to go through the tuples. We're going to do multiple assignment again. Each element in a pairs list is a tuple. The first one is the word. The second one is the count. We're going to print them out in nice columns, and what we'll do is it'll be 4 columns long. If the column's 3, then we're going to print it out with a carriage return to make it look nice. For frequency, we have to do very few changes. One change that will change is that pairs lists iterate through the items, but when we store the tuples, we're going to store the value first, so that when we do the sort, we're going to sort those items in value order. Then when we do the printout, we'll get in frequency order as opposed to alphabetical order. So let's see if that works. All our functions are defined. Let's call the main function, see what happens. So there were 138 words that was printed in the main function. Here are the words in alphabetical order. Here are the words in frequency order.